Hey there everyone. Today we are going to discuss acids and bases and the basics of writing their formulas and naming them. This is covered in section 9.4 of your textbook. Let's begin with the definition of an acid. An acid is defined as an ionic compound that contains hydrogen. So that's key. You have to have hydrogen of some sort in the compound for it to be an acid. And when you put acids in water, they will produce H+ or hydrogen ions. So the general formula for an acid can be represented as HNA or HNX. Your textbook uses the HNA version, but or the HNX, sorry, but I use the HNA because that's how I learned it from another textbook. But the similarities here are that the H represents the hydrogen. The subscript of N tells you the number of hydrogen atoms needed to make the compound neutral. And the A or the X represents the anion. Remember, anions are negative ions. Okay, so let's take a look at H2SO4. This is clearly an acid since it begins with hydrogen. If you were to put H2SO4 in water, it would break apart into H+ ions, but we have a subscript of 2, so there would actually be 2 H+ ions. I tell my students kind of break this apart, the hydrogen from the anion. So you would get 2 H+ ions, and then you would get an SO4 2- anion out of this. The 2 came from uncrossing this compound. Remember how ionic compounds are type 1, type 2, where you crisscross. So this is an acid that is made from H+ ions and the sulfate ion. So if we were going to talk about how you name acids, just like we had 3 different categories of binary compounds, type 1, type 2, type 3, there are 3 different types of acids. The first set of rules is when the anion in the acid ends in "ide," the acid is named using the general form of hydroblankic acid. So let's start with HCl. If you put HCl in water, it's going to break apart into 1 H+ ion. Like I said, break it apart, hydrogen and anion, and then you will get the Cl- anion. And if we think back to what we have already learned, Cl- is the chloride ion. So we've got this type of acid that we were talking about. So if this came from the chloride ion, HCl would be named hydrochloric acid. And you do have to write acid at the end of it. All acids have acid at the end of their name. All right, next, HF. Let's look at what HF is made of. So if I were to divide this up between its hydrogen and the anion, this is made from 1 H+ ion plus 1 F- ion. And the name for the F- ion is fluoride. This is yet another reason why learning the names of your ions is going to become really, really helpful. So if this was the fluoride ion, let's think back. Chloride turned into hydrochloric acid. So fluoride will make the hydrofluoric acid. Whoops, misspelled that, sorry. Fluoric acid. All right, let's take a look at HCN. So if we were to divide off the acidic hydrogen here, you would get 1 H+, and then you'd be left with Cn-. And if you look at your ions list, Cn- is named cyanide, another ide ion. So HCN is the acid named hydrocyanic acid. Again, these all follow the general rule of hydroblankic acid. Not all of your anions, though, will end in "ide." When the anion ends in "ite," then the acid is named using an "us" suffix. So let's take a look here. HNO2. If I were to break this apart and take off its acidic hydrogen, I would get 1 H+, it's 1 H+ because there's only 1 hydrogen, plus an NO2-. And if I go to my ions list, NO2- is called nitrite. So we've got an ite ion, and my rule tells me this becomes an acid. So HNO2 would be known as nitrous acid. I believe that nitrite is the only ite ion on your list, so that's the only example that I'm going to give. When you move on to other classes, though, there are several other ite ions out there. We just don't cover those in our particular class. What about the third option for anions? What about if it ends in an 8 ion? So if it's an 8 anion, then the acid is named with the ic suffix. So if we take a look at HNO3, notice very close to what we just did, but what we just did was HNO2. So if I divide off my acidic hydrogen here, HNO3 is going to make H plus NO3 minus. And NO3 minus ion is nitrate. So my rules say if it's an 8 anion, it becomes an ic acid. So HNO3 would be named nitric acid. Let's take a look at H3PO4. Again, we divide off the hydrogens. This time, there was a subscript of 3 next to the hydrogen. So that means that there are 3 H pluses that are going to be made. And you have a PO4, and that 3 originally came from the fact that it's PO4 3 minus, because we would uncross this. So PO4 3 minus is named phosphate ion. 8 ions become ic acids. This is called phosphoric acid. I'm not gonna lie, as you learn this, you will become more familiar with where you cut off the root words. A lot of beginning chemistry students will call that phosphic acid. I would be lenient and give you full credit because you were trying to put the ic on it, but it's better practice to call this phosphoric acid, kind of like with sulfur, it becomes sulfuric acid or sulfurous acid instead of sulfic or sulfus acid. Just kind of say it out loud and see which one sounds better, but you definitely need to change the 8 ion to an ic acid. Bases are a little bit more straightforward. Bases, again, are ionic compounds, but they will produce hydroxide ions in water. And remember, hydroxide is OH minus. As far as the formulas and names go for bases, it's a lot simpler. There's just one rule. You follow the same rules as type 2 or type 1 compounds. So if I take a look at aluminum hydroxide, again, this is a base because it has hydroxide. Aluminum is the Al3 plus ion. Hydroxide is OH minus. So we crisscross here. A lot of times as students are learning this, I will see them write AlOH3. The problem with writing that way is this puts the 3 only on the hydrogen and just 1 oxygen. We need 3 of the entire hydroxide ion. So you need to put parentheses around your hydroxide ion. Whoops, that was not good. I erased way too many things. Okay, how about that? So you would best write this as AlOH3. Then if we were to flip this around, and this time I gave you the formula, so it's CaOH2, notice there's parentheses with the 2 outside. This would be called calcium because calcium is Ca hydroxide because it has an OH minus. And that is the basics of acids and bases and how you name them and write their formulas. For more information, please see section 9.4 of your e-text.